Appendix D, Letter J.E. Lip to Brigadier General Putt, Project Sign, 13 December 1948. Dear General Putt, the present letter gives, in very general terms, a description of the likelihood of a visit from other worlds as an engineering problem and some points regarding the use of space vehicles as compared with descriptions of the flying objects.
We're now in the approach phase, everything looking good. Altitude 5,200 feet.
Controllers, gonna go for landing.
No.
Control. GNC.
Sergeant. Go.
Captain Onward, go for
Altitude
landing.
42, Houston, you're go for landing.
Over 3,070.
Welcome to the Alien Probe Snippet with Dr. Bill. Many modern astronomers believe that planets are fairly normal and logical affairs in the life history of a star rather than cataclysmic oddities, so that many planets can be expected to exist in space. To narrow the field a little, some loose specifications can be written for the star about which the home base of an alien civilization would revolve. Let us say that the star should bear a family resemblance to the Sun, which is a member of the so-called main sequence of stars, i.e., we eliminate white dwarfs, red giants, and supergiants. There is no specific reason for making this assumption except to simplify discussion. We are still considering the majority of stars. As our best known sample of space, we can take a volume with the Sun at the center and a radius of 16 light years. A compilation of the 47 known stars, including the Sun, within this volume. 3 are white dwarfs, 8 binaries account for 16 stars, and 2 trinaries account for 6 more. The remainder 22 stars can be considered as eligible for habitable planets. Having an estimate of the number of usable stars, it is now necessary to make a guess as to the number of habitable planets. We have only one observed sample, the solar system, and the guess must be made with low confidence, since intelligent life may not be randomly distributed at all. The Sun has 9 planets arranged in a fairly regular progression of orbits that lends credence to theories that many stars have planets. Of the 9 planets, one, the Earth, is completely suitable for life. Mars has extremely rigorous living conditions, and Venus has an unsuitable atmosphere. Viewed very broadly indeed, this could mean that each star would have a series of planets so spaced that 1 or possibly 2 would have correct temperatures, correct moisture content, and atmosphere to support civilized life. Let us assume that there is, on the average, 1 habitable planet per eligible star. There is no line of reasoning or evidence which can indicate whether life will actually develop on a planet where the conditions are suitable. Here, again, the Earth may be unique rather than a random sample. This writer can only inject some personal intuition into the discussion with the view that life is not unique on Earth, or even the random result of a low probability, but is practically inevitable in the right conditions. That is to say, the number of inhabitable planets is equal to those that are suitable. One more item needs to be considered. Knowing that nothing at all about other races, we must assume that man is average as to the technical advancement, environmental difficulties, etc. That is, 1/2 of the other planets are behind us and have no space travel, and the other half are ahead and have various levels of space travel. We can thus imagine that in our sample volume there are 11 races of beings who have begun space explorations. Earth would possibly be reached only after many centuries of development and exploration with spaceships, so that a visiting race would be expected to be far in advance of man. To summarize the discussion thus far, The chance of space travelers existing at planets attached to neighboring stars can be viewed almost as certainty if the assumptions are accepted, whereas the other is very slight indeed. Let us assume the inhabitants of neighboring stars have developed nuclear hydrogen-propelled vehicle, the most efficient basic arrangement that has been conceived here on Earth. Requirements for a trip from a planet attached to some star other than the Sun can be calculated. Here, the energy or velocity requires several parts. A, escape from the planet. B, escape from the star. C, escape velocity to traverse a few light years of space in reasonable time. D, deceleration toward the Sun. E, deceleration towards the Earth. The nearest eligible star is an object called Wolf 359 at a distance of 8 light years. It is small, having an absolute magnitude of 16.6, and is typical of red dwarfs, which make up more than half of the eligible population of local stars. By comparison with similar stars of known mass, this star is estimated to have a mass roughly 0.03 as great as the Sun. Since the star has a low luminosity, being much cooler and smaller than the Sun, a habitable planet would need to be in a small orbit for warmth. If a race were far enough advanced to make really efficient use of nuclear energy, then a large part of the mass of the nuclear material might be converted into jet energy. Using an efficiency of 50% for converting nuclear energy to jet energy and neglecting relativistic mass corrections, then a rocket velocity of half the velocity of light could be attained. This would mean a transit time of 16 years each way from the star Wolf 359, or longer times from other eligible stars. Combining the efforts of all science fiction writers, we could conjure up a large number of hypothetical methods of transportation like gravity shields, space overdrives, teleports, simulators, energy beams, and so on. Conceivably, among the myriads of stellar systems in the galaxy, one or more races have discovered methods of travel that would be fantastic by our standards. Yet the larger volume of space that must be included in order to strengthen this possibility, the lower will be the chance that the race involved would ever find the Earth. The number of stars in the known universe is enormous. Yet so are the distances involved. A super race, unless they occur frequently, would not be likely to stumble upon Planet 3 of Sol, a 5th magnitude star in the rarefied outskirts of the galaxy. A description of the probable operating characteristics of spaceships must be based on the assumption that they will be rockets, since this is the only form of propulsion that we know will function in outer space. Below are listed a few of the significant factors of rocketry in relation to flying objects. A. Maneuverability. A special purpose rocket can be made as maneuverable as we like, with very high accelerations either along or normal to the flight path. However, a high-performance spaceship will certainly be large and unwieldy and could hardly be designed to maneuver frivolously around the Earth's atmosphere. The only economical maneuver would be to come down and go up more or less vertically. B. Fuel reserves. It is hard to see how a single rocket ship could carry enough extra fuel to make repeated descents into Earth's atmosphere. The large number of flying objects reported in quick succession could only mean a large number of visiting craft. Two possibilities are thus presented. First, a number of spaceships could have come as a group. This would only be done if full dress contact were to be established. Second, numerous small craft might descend from a mothership which coasts around the Earth in a satellite orbit. But this could mean that the smaller craft would have to be rockets of satellite performance, and to contain them, the mothership would have to be truly enormous. C. Appearance. A vertically descending rocket might well appear as a luminous disk to a person directly below. Observers at a distance, however, would surely identify the rocket for what it really is. There would probably be more reports of oblique views than of end-on views. Of course, the shape need not be typical of our rockets. Yes, yet the exhaust should be easy to see. One or two additional general remarks may be relevant to spaceships as flying objects. The distribution of flying objects is peculiar, to say the least. As far as this writer knows, all incidents have occurred within the United States, whereas visiting spacemen could be expected to scatter the visits more or less uniformly over the globe. The small area covered indicates strongly that the flying objects are of earthly origin, whether physical or psychological. The lack of purpose, apparently, in the various episodes is also puzzling. Only one motive can be assigned, that the spacemen are feeling out our defenses without wanting to be belligerent. If so, they must have been satisfied long ago that we can't catch them. It seems fruitless for them to keep repeating the same experiment. Conclusions. Although visits from outer space are believed to be possible, they are believed to be very improbable. In particular, the actions attributed to flying objects reporting during 1947 and 1948 seem inconsistent with the requirement for space travel. Very truly yours, J.E. Lipp, Missile Division, RAND Corporation. This has been the Alien Probe Snippet with Dr. Bill. Till next time, bye-bye.